Now start the second chapter of paper real analysis, and the chapter is sequence of real numbers. Sequence of real numbers. Okay. The first thing is definition of sequence. First thing is definition of sequence. A sequence S of real numbers is a function from the set of positive integers I, into the set of real numbers R. It means what? It means a sequence S is function from set of positive integers I into the set of real numbers and is defined as, that means image of integer I, positive integer I, is assigned to be Si, where this I is a positive integer, and Si, the output Si, is a real number. That means it is denoted as sequence S to be, it is denoted by the sequence Sn of real numbers, and n varies from 1 to infinity. That means we write this sequence in curly bracket by writing the nth term. So we sometimes write sequence S as first term S1, second term S2, third term Sn, ith term Si, and so on, where this Si is the ith term of the sequence Sn. Where n varies from 1 to infinity. So let us see some examples. So let the nth term Sn is n for all positive integers n. Then what the sequence can be if the nth term of the sequence is n, where n varies from 1 to infinity. So the sequence will be 1, the first term for n equal to 1, the second term for n equal to 2 is 2, the third term for n equal to 3 is 3, the fourth term for n equal to 4 is 4, and so on. And definitely is the sequence of positive integers, right? It is the sequence of positive integers. Second example, let me take the nth term to be 1 for all positive integers n. Then what can be the sequence? So it will be the nth term for any natural number n, any positive integer n is 1. That means it is fixed, constant. So for n varies from 1 to infinity. So what can be the sequence, or what can be the terms of the sequence? The first term for n equal to 1, it is 1. The second term for n equal to 2, it will be 1. The third term will be 1, and that means it is a constant sequence. Is a constant sequence. Right. The next example, let me take the first term to be 1, the second term to be 1, and we define the n plus first term of the sequence is to be n minus first term plus the nth term of the sequence, and it is for all positive integers n. Then can you guess what can be the sequence? So the first term we have defined it is 1, the second term we have defined is 1, the next term, so what can be S3? So for n equal to 2, if I use this thing, so it will be for n equal to 2, it will be S3. So when n is 2, it will be S1 plus S2. So that means the n plus 1th first term is addition of nth and n minus first term, right? That means S3 will be addition of S1 and S2, right? So 1 plus 1 is 2. What can be S4? Definitely it will be addition of S3 and S2. So it is 3. What can be S5? Definitely it will be addition of S4 and S3. So it is 5, and continuing by this way. Right? And it is a special kind of sequence, is a sequence, it is called as, it is sequence of real numbers, and is called as a Fibonacci sequence. A Fibonacci sequence or a Fibonacci numbers. The next example, let the nth term of the sequence is 1 by n for all positive integers n. Then the sequence S will be the sequence, the nth term. The nth term written in the curly bracket will represent definitely a sequence. So the nth term is 1 by n. So what will be the first term for n equal to 1, for n equal to 2, the second term, for n equal to 3, the third term, for n equal to 4, the fourth term, and so on. Similarly, the nth term, if I take, it is minus 1 raised to n for all positive integers n. Then this sequence will be, what the sequence will be? Minus 1 raised to n. So the first term for n equal to 1, it will be minus 1. The second term for n equal to 2, it will be plus 1. Again the third term for n equal to 1 will be, n equal to 3 will be minus 1. The fourth term for n equal to 4 is plus 1. So it is the sequence of plus 1 and minus 1. Right? So it is also a different kind of sequence. The next example, let S equal to, and let me define it as 1, 0, 1, 0, 1, 0, 1, 0. So I have written the real numbers 0 and 1 alternately. Right? So it is also a sequence of real numbers. It's also a sequence of real numbers. So for a sequence, does there exist a subsequence? So yes, there exists a subsequence. So we see the definition of subsequence. a subsequence n of that means it is sequence of positive integers. So that is a sequence of positive integers. So that means a subsequence of positive integers is a function from I, set of positive integers, into I, the set of positive integers, such that n of I is less than n of j. Any two positive integers are comparable. For all integers, positive integers I and j, they are different from each other. Right. So for example, if I choose positive integers 1, 3, 5, 7 and so on, the odd positive integers, it can be a subsequence of set of positive integers, right? And similarly, the set of even positive integers, that means 2, 4, 6, 8, is also a subsequence of set of positive integers 1, 2, 3, 4, 5 and so on. So the definition of subsequence: if S, that means it can be written as sequence Sn, is a sequence of real numbers, and n, which is denoted by ni, when I varies from 1 to infinity, is a subsequence of the sequence of positive integers. Then the composite function S composite n, is called a subsequence of S. Try to understand. Suppose S is a sequence of real number and we choose n is sequence of positive integers, and then the composite function S composite n. That means we know that if S is sequence, so it is function from set of positive integers to set of real numbers. And as we have seen, the subsequence of positive integer, so suppose n is subsequence of positive integer, it is function from I to I, right? Then, so that means under this map, positive integer I will map to some real number Si, and under this map n, it is subsequence, so I maps to some ni, right? So let me define, or let me express the composite function. Then the composite function S composite n, it will be function from I to R, set of positive integers to R, and is can be defined as, the definition of this composite function will be defined as S composite n of I. So it will be S of n of I. It should be true for all positive integers I. So it is equal to S of ni, because we have defined n, and it will be Sni. So this is the nth term of the function S composite n. That means it is the term of subsequence of the sequence S. Thus, the composite function or a subsequence is denoted by this nth term of the subsequence when I varies from 1 to infinity. For example, let S equal to, I will take it as 1, 0, 1, 0, 1, 0, 1 and so on. So we define n, the set of integers, the sequence of positive integers, by the definition. The nth term is defined as 2i minus 1 for all positive integers I. Then what will be the subsequence? Then S composite n will be S of ni. What is ni? S of ni, right? So it is S of ni, and S of ni is S of 2i minus 1. So it is S2i minus 1 for all positive integers I. So thus S composite n is it represents the 2i minus first term of the sequence when I varies from 1 to infinity. So what is the first term of this subsequence? For I equal to 1, it is 2 minus 1 is S1, and S1 is 1. Then let me write the places first. For I equal to 1, it is S1. For I equal to 2, it is 4 minus 1 is 3, S3. That means the first term of the subsequence is the first term of sequence. The second term of subsequence is third term of sequence. For I equal to 3, it is S5. For I equal to 4, it is S7 and so on. So what the actual real numbers in that place of S1, S3, S5, S7 in the sequence S? So they are 1, 1, 1, 1. Right? So it is a subsequence of sequence S. So similarly, if we define this ni to be in this place, if we define ni to be 2i for all positive integers I, then the S composite n, will be S2i. I varies from 1 to infinity. So what are the places of the term? So for I equal to 1, it will be S2. For I equal to 2, it will be S4, S6, S8 and so on. So what are the elements? What are the terms in the original sequence S? So they all are the term 0 and is also a subsequence of S. Is also a subsequence of sequence S. So for examples, it is second example. So let Sn be the sequence defined by the first term is 1, the second term is 2, the n plus 1th term is Sn plus Sn minus 1, and it is true for all integers n greater equal 3. And question is, find the 8th term of this sequence. So how to find? So we have given S1, S2 and the definition of Sn plus first term. So therefore S3, I have S1 and S2. It is given S1 is 1, S2 is 2 and Sn plus 1 is Sn plus Sn minus 1 for all n greater equal 3. So I have S1, S2. So what can be S3? For n equal to 2, I can find S3 will be S2 plus S1. So it is 2 plus 1 is 3. Sorry, S2 is 1. Sorry, S2 is 1. So it is S2 plus S1 is 1 plus 1 is 2. Then S4, for n equal to 3, it will be S3 plus S2. S3 is 2, so it is 2 plus 1 is 3. Then S5, for n equal to 4, it will give S5, so it is S4 plus S3. S4 plus S3, it is 5. Next term X6, so for n equal to 5, it will give S6. So it is S5 plus S4. So it is 8. Then S7. For n equal to 6, it will give S7. So S6 plus S5. So it is 13. And S8 is for n equal to 7, it will give S8. So S7 plus S6. So it is 21. And definitely the 8th term of the sequence will be 21. Right. Next example. Write the formula for sequence Sn. The sequence is 1 0 1 0 1 0 and so on. So how can you define the sequence? How can you provide some formula for this sequence? The first term is 1, the second term is 0, the third term is 1, the fourth term is 0. So in the odd places I have real number 1, and in the even places I have the odd numbers, the real number 0. So I can define the nth term to be 1 if n is odd, and the nth term will be 0 if n is even integer for all positive integer n. Right? The next example, 1 3 6 10 15. Can you guess how we can provide some formula? The first term is 1, the second term is 3, the third term is 6. So what is the relation in this case? Can you guess? So we can define Sn to be n plus Sn minus 1. Try to check whether it is actually is it true. The next sequence 1 minus 4 9 minus 16 25 minus 36 and so on. So can you give the formula? The first place it is 1, the second place it is minus of 4, that means square of 2, but the sign is minus. This is square of 3, this is square of 4, but the sign is minus. So definitely n square is there, but the minus sign, plus and minus sign are occurring alternately. So what we can give here? Minus 1 raised to definitely it is not a square. So if I write it is raised to n plus 1, so in the first term it will be square, in the second term it will be minus, right? Yes. So it is true for all positive integers n.